Hi guys, so little lesson about this. I made my video already today and it was about 19 minutes. And then when I went to upload it, it didn't because it was too long. So now this is take two and it will be in two parts. So this lesson today, two videos. Sorry about that. Kate, thank you for being very patient. All right, so my first part's going to be maybe about 10 minutes. Second part's going to be maybe about 9 because that's how long the other video was. But I'm just going to go through the same problems I did before. Okay, so on my properties, I wrote them out for today. On 10.2, we're doing product properties. And a couple people have been asking and sending in messages about, should I write these notes down? Should I write them in my composition book? Well, guys, it's going to be up to you because there's going to be two quizzes this chapter, one on exponents and then one on scientific notation. But it's all up to you. You can rewatch these as much as you want. I don't care. Today, we have the lovely Pirates of the Caribbean ears. That's the pirate ship. And my Dead Men Tell No Tales shirt. Woohoo! In case you're wondering. Anyways, here we go. And I'm going to go fast. Here we go. So product properties. There's 3 product properties that you can use with exponents. The cool thing is you do not need to memorize them. I'm going to show you how you can still use the properties without memorizing each name and that kind of thing. Here we go. First one, product property. I renamed this one. This in your book is called the product of powers. And the reason why I renamed it is because there's so many P words when we're talking about all these properties. And I just thought this would be a little bit easier to keep track of. So I just renamed it as the basic product property. This is your most basic exponent rule. What it says is if you have the same base, whatever, A, and you raise it to a power, then what you're going to do is you're going to add your exponents. Okay? So now the base has to be the same in order to add those exponents. Your base can be a variable or it can be a number. Does not matter. Next, we have power of a power property. And what that means is if you have some power, a to the m, and then you're going to raise that to a power, then what you're going to do is you're going to multiply your exponents. So this quantity has a power and it's being raised to a power. That's why it's called power of a power. So this is the power of a power. And you multiply your exponents. The next one, power of a product. So you're going to have something being raised when something is being multiplied. So in here you have the quantity AB to the mth power. And what that means is you're going to take each part, I call it a part, but it's actually a factor. You're going to raise each one of those to the same power. So each part gets that power. So you can have variables, you can have coefficients, you can have 2 terms, you can have 5 terms, you can have 10 terms, you can have 17 terms. It really doesn't matter. But each part, meaning the factor, gets that power. So in a way, it's like saying m is going to distribute to each little factor in a way. Okay, so we got to be careful with that. But these are your properties. And I will take a picture of these and put them in your notes. Okay? All right. So, first up, example 1. So this is example 1. And this is multiplying powers with the same base. Okay. Here we go. We have 2 to the 4th times 2 to the 3rd. All right? And so, is the base the same? What is the base? Yes, it is. The base is 2. So, since the base is the same, you can add your exponents. So, we have 2 to the 4 plus 3, which gets you 2 to the 7th power. But the cool thing is you do not need to use your properties this whole time. You can expand it, and here's what it looks like. And after watching my first video, now that I have to redo it, I'm not going to expand every single problem. If you need more help on expansion, send me a message with your number, and I'll call you back. Okay? Here we go. Here's what it looks like expanded. What is being raised to the 4th? 2. How many times? 4. And then we're going to multiply that by 3 more 2's. So you can write it all out. You don't have to use your properties. And then on here, this is what we worked on yesterday. What is your base? 2. How many times is it being multiplied? 1, 2, 3, 4, 5, 6, 7. So you still get the same answer, and it doesn't matter which way you do it. Sometimes it's going to be easier to go with the exponent rules. Sometimes it's going to be easier with expansion. You're just going to have to kind of wait and see, and also takes years of practice and years of working with exponents to do this. Okay? Now I know you algebra kids have already done exponent work. You have to show all your work, just like everybody else does. All right, so now you can do this with variables as well. You can go x to the third times x to the second times x to the third. Is the base all the same? Remember, the base is x. And since yes, it is, you can add them. Okay? So we have 3 plus 2 plus, am I just going to skip to this next 3? No, because if this guy is here, it matters. So that means you have to have a power of 1. So plus 1 plus 3. And that equals 3, 4, 5, 6, 7, 8, 9. X to the 9th power. And if I expand this problem, it's going to look like this. All these x's. So I'm not going to expand this one. But it's going to look like that. So you would have 3 x's written out, 2 more x's, another x. You've got to include that one. And then 3 more x's. And then just count them all up. And then you still get the power of 9. Okay? I got to watch my time. And then, remember how I said yesterday, don't drop the parentheses? You can't on negatives. Do not drop parentheses. My face looks really weird this close. All right, I'm backing up. Here we go. So the problem, -5 times the quantity -5 to the 6th. So in your book, they did not put parentheses around this guy. It is still saying -5. The reason why they didn't is because there's no power there. It is the same as putting parentheses around this guy. And since it's there, it matters. It has a power of 1. So now it looks like you still have the same base. Now you can add your exponents. So you have the quantity, -5, to the 1 plus 6, which equals the quantity, -5, to the 7th power. And you can expand this just like you did up here. You would write 1 -5 and 6 more -5s. And you'd want to put those in parentheses just to keep the negatives separate, kind of a thing. Okay? So that's using the first product property. When everything here, the base has to be the same. That's the only time you can use that property. The base has to be the same. So this guy's got to be the same. That guy's got to be the same. All right? If you added a different variable in here, it's not going to be the same. Therefore, you cannot use that. I didn't write it. You can't use the product property. Okay? There we go. All right. Now, I'm going to move on to the second example. So, example 2. Hopefully you guys are doing well today. It's a nice snowy day. The dog is tucked in our bed upstairs because he's a little bit of a snuggler. Okay, so example 2. Power of a power. And I will probably cut this video off after 1 or 2 problems, and then I'm going to do the last part. Or it depends on how fast I can talk, because I'm at 8 minutes right now. Here we go. Power of a power. So you have something that's being raised to a power, and then we're going to raise that to a power. So we have the quantity 3 to the 4th being raised to the 3rd power. This is why parentheses are so important. If you guys just read this off, 3 to the 4th to the 3rd power, what does that actually mean? So that's why these parentheses are really important. You've got to pause when you say that. So it's the quantity 3 to the 4th power cubed, or to the 3rd power. Okay? So power of power says you can multiply your exponents. So you have 3 to the 4 times 3, and you can drop your parentheses because it's not negative. So you have 3 to the 12th power. Okay? I also notice I say K a whole lot in my videos. I need to work on that. All right. Or expanded, what I want you to ask is, what is being raised to the 3rd power? So you should have 3 of whatever's inside those parentheses. And it does not matter what's in there. Whether there's numbers or happy faces or variables or anything. You're going to write out whatever's in those parentheses 3 times. So you have 3 to the 4th times 3 to the 4th times 3 to the 4th. Okay? Now, this gets back down to example 1. Now you're going to expand this part. Okay, I'm going to cut off this video after this problem. So 3 times 3 times 3 times 3. That's the first part. Times 3 times 3 times 3 times 3. That's the second one. And, of course, I ran out of room. Times 3 times 3 times 3 times 3. What is the base? 3. How many times is it being multiplied? 12. Count on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So it really doesn't matter how you do this. You can just expand it all. All right? Same thing with variables. I think I'm going to try and do this in one video. So we have this guy. How do you say it? The quantity w to the 5th to the 4th power. So how many w fifths do we have? We have 4 of them. If you use your properties, it's w to the 5 times 4, which is w to the 20th, which is 20 w's written out. That's a lot. I'm not going to expand it, but it would look like this. I'm going to do part of it. Nope, not 3. W to the 5 times w to the 5 times w to the 5 times w to the 5. And then you do this part like you did that part. Sound good? All right, I'm going to cruise on. I'm going to make this a fast video. I got to try and keep them all under a certain time so that way I don't have to do 2 separate videos because this whole uploading thing is kind of being a pain in the butt. But technology, I'm doing good at it. All right, here we go. Example 3. I feel like I'm like in a race for who can talk the fastest. Power of product. My voice is cracked. Now, here's the thing. Do not let the name of this example fool you because it says you're using power of product, but you could also be using other properties. So, we got to be careful. First example, the quantity 2x to the 3rd. So this is your product, 2 times x, that's your product, and we're going to raise that to the 3rd. So we have 3 of everything that's inside, or if you use your property of exponents, you can just make sure each little part gets the power. So you have 2 to the 3rd, x to the 3rd. All right? Can you do anything more with this? Yes. So 2 to the 3rd, which is 2 times 2 times 2. So you have 8x to the 3rd. Can you do anything more with that? No. So you're done. A quick expansion. So you have 3 of whatever's going on in here. 2x times 2x times 2x. You could even group them all together. 2 times 2 times 2 times x times x times x. And you still get 8x to the 3rd. Same answer. So it just depends on how you want to show your work and how you want to expand it. All right? So it doesn't matter how many factors are in here. Each little part gets that power. So let's go, let's do 3, I don't know, let's go a.m. to the 2nd. I wonder who a.m. is. First period? I don't know. Here we go. So each little part gets this power. So we have 3 to the 2nd, a to the 2nd, m to the 2nd. Can you do anything more here? Yes. 3 to the 2nd, which is 9, a to the 2nd, m to the 2nd. Can't do anything more with that. You're done. All right? All right, one last problem. I'm looking at my time. I'm gonna do a tricky one. So we have 16 times the quantity 1/2 x to the 4th. Real quick, what is being raised to the 4th power? Is this whole thing? No, it's just the quantity 1/2 x to the 4th. So when you're trying to figure out what's being raised to a power, this exponent is going to hug whatever is being raised, okay? So it looks like 16 times, each little part gets the power, 1/2 to the 4th times x to the 4th. I got to hurry up. 1/2 to the 4th. That 16 times, I'm going to do this down here, 1/2 times 1/2 times 1/2 times 1/2. 1 times 1 times 1 times 1, 1. Over 2 times 2, 4. Another group of 4, 16. Times 1/16 times x to the 4th. Here we go. 16 over 1 times 1/16, that is 1 x to the 4th. Do you need this one? No, you don't. And you end up with x to the 4th. That was a big problem. All right? Okay, guys. I'm going to try and upload this. I know it went super fast. If you have questions, send me your number and I'll call you. By the way, the extra credit. what was behind me the whole time. Bye. Comment here.